Alright, so welcome to Algebra 2. We're starting in Chapter 1, and in Chapter 1 we're going to learn about the real numbers and its operations. But before we do that, let me introduce you to the complex numbers. We're going to touch on this later on in a few chapters, around Chapter 5 or Chapter 6 of the Algebra 2 textbook. Now, complex numbers are comprised into two different categories, the real numbers and the imaginary numbers. We're not going to focus on them as I stated today, but we're going to focus on the real numbers. Now, the real numbers are any type of number that you can think of. I am assuming that you have not heard of imaginary numbers, and therefore every single number that comes to your mind is a real number. What we use many times to help us to visualize how the real numbers look is what we call the real number line. Now notice with this line there are two arrows on either end. Those two arrows indicate that you're going on forever in either direction. One to positive infinity, the other side to negative infinity. You might have heard the statement to infinity and beyond. It simply means that there's no capping stone to how you can count. Now what you see also in the middle is the origin, or zero. Also in the word origin you get originate or original. It's the starting point or the emanating point. Now on either side of the zero or the origin you see the positive numbers and the negative numbers. The negative numbers are indicated by the little hyphen in front of the number, and it simply indicates you have gone lower than 0. Now, what you see negative 2 and 5/10. You see negative 0.3 with the line on top, the vernacular. You also see the quarter, 1/4, square root 2, pi, and the mixed number, 4.5. And we're going to touch on more what these numbers represent. Now, once you get to the real numbers, it splits off into two subgroups. The rational numbers and the irrational numbers. This is the two most important things you definitely want to remember because a number can be either rational or irrational. Now you see a little description down below, but we're going to go a little bit deeper to what these mean. Here you see on the screen the definitions of the two different terms. Now the rational numbers, you can get an understanding of it just by the prefix of the name rational. You see in the prefix ratio. Now, numbers that can be written as a ratio of two integers are also known as fractions. So basically, the rational numbers is any number that can be written as a fraction. So if you see a number in fractional form with two integers, and we'll talk about integers soon, then they will be called rational numbers. Also, fractions can be rewritten as decimals. And so in terms of a decimal number, a rational number is a terminating or repeating decimal number. Now that or is important because it can be either or. It does not have to be both descriptions to satisfy being a rational number. Here's some examples. We have a half, which equals to 5/10, commonly known as 0.5. Notice as a decimal, that number terminates. And by terminate, I mean it does not go on forever. It stops at the 5. And so a terminating decimal is considered a rational number because you can turn that rational decimal into a fraction, which you will have to do later on in algebra. Then we have 2 1/4 as a mixed number, which can be rewritten as a decimal number as 2 25/100. Now 2 25/100 is a terminating decimal, which means it's a rational number. Then we have a third. Now a third has a unique property that when you turn into a decimal, and you can try this on your calculator by putting 1 divided by 3, it will turn into a number that does not end. It doesn't terminate, but it repeats. And because it repeats, it's still a rational number. And that's why it can be either or, a terminating decimal or a repeating decimal. Then on the other side, we have what's called the irrational numbers. Now, the word title irrational simply means it's the opposite of whatever the rational numbers are. Now, since the rational numbers can be written as a fraction, the irrational numbers cannot be written as a fraction or as a ratio of two integers. As a decimal, they're non-terminating and non-repeating. That simply means that non-terminating, they will never end. They go on forever. But notice the conjunction and means that you have to have this secondary characteristic, and that is they are non-repeating. There will never be a pattern, never, ever, ever in any of these decimal numbers. And so when you see a number that goes on forever and does not repeat, you know that it's irrational. So here we have square root 2 is approximately 1.144213562, and the three dots, the ellipses, means that goes on forever. And then for pi, you should know about pi through geometry and trigonometry. And generally, you're taught that it's 3.14, but that's not entirely correct. That number is an irrational number, and 3.14 is the rounded version of that. And the actual number is 3.141592654, going on to infinity. Then we have square root 3, which is approximately 1.732050808, followed by a multitude, infinite amount of digits. Now, one thing I have to point out is what you see on the bottom. That little squiggly line means approximately. It's an approximate answer because it's so many other digits that are following that when you cut that off, it kind of changes the value. So you cannot use the equal sign. Whenever you approximate an irrational number, you must, in algebra, you must have the approximation sign. So just remember that as we move on. And that means for every chapter from now on, chapter 1 right on to chapter 14 of algebra. Now the other thing is that with the roots or the radicals, the square roots, what you see here, whenever you take the square root of any number that's not a perfect square, and we will touch more on what perfect squares are if you don't know, then it will be irrational. So square root 2, square root 3, they are irrational. But when you take the square root of 4, if you try that on your calculator, you notice you get a rational number. You get the number 4. Sorry, the number 2. The square root of 4 is equal to 2. And you would use the equal sign because that's the actual answer. And because the answer is rational, it means square root 4 is rational. But square root 5, if you try that, that's irrational. If you try it again with another answer, square root 9, that will give you 3. Square root 16 will give you 4, and so forth. Those are what we call our perfect squares. And when you take the square root of those numbers, you get a rational number. Any other type of number that you take the square root of will be irrational. Okay, so let's go back to our real number line. So what we see there are all the different types of numbers, rational and irrational, and the origin in the middle. Now, if we keep on going, we have our real numbers split up into rational numbers and irrational numbers. If we go underneath the rational numbers, you get what's called the integers. Now, the integers represent something significant. They are basically our positive whole numbers, which are 1, 2, 3, right on to infinity, and our negative numbers, which start from negative infinity down to 1, and then 0. Combined all together, we see this nice color coordination of the red numbers being negative 0, which is purple, in the middle, our origin, and then our positive green numbers on the right. Now, with the integers, there are no fractions or decimals involved. They are only the whole numbers, and by whole numbers, we'll touch on that a bit more, the regular numbers that you're used to using. When you count the amount of cars, you don't say you see 2.5 cars if you're counting the cars in a parking lot, because that means the car would be cut in half, but you're counting the actual cars that are there. And so those type of numbers, we call them integers. Now, with the integers, it sometimes helps us to use what's currency or money. So if you put a dollar sign on there, it makes it a little bit easier to understand, where the positive side represents being in the green, having money, whereas being in the red means you're negative. That means you owe someone money. And in the middle, that just means you're broke. So imagine if you're broke, you have no money, and then you decide to borrow money. Well, now you're in debt. You are in the negative realm. And so those negative numbers, the negative sign, the little hyphen in front of the digits, they represent that you are now below 0. And the further left you go is the smaller the number gets. And the further right you go, the larger the number gets. All right, so now if we keep on going, integers was a subgroup of the rational numbers, but integers also has a subgroup that's right underneath, and that's called the whole numbers. And the whole numbers are numbers that we're normally used to seeing while you were in elementary school or middle school. The whole numbers include the positive numbers and 0. Those are the numbers that the average person knows right up until about middle school when they start algebra. Now the whole numbers always start at 0, so you have to remember that. You must include 0 and then go on to infinity, as you see here on this graph. 0 is the origin, so it has no arrow on that side, and then the arrow indicates you go on to forever to positive infinity. Now the whole numbers has the last group, our last subgroup that falls underneath each of these categories are the natural numbers. And we call them natural because it's the natural way of counting. And so they're also known as the counting numbers. So if I ask you to count how many toys you have in your room, you will start at the number 1. So you note that 0 is not included when speaking of the counting or natural numbers. All right, so 0 is not included there. Now, if we were to put this into a nice graphic, what you will see is that the natural numbers are a subset of the whole numbers. The whole numbers are a subset of the integers. The integers are a subset of the rational numbers. And then the rational numbers and the irrational numbers both are subsets of the real number system. And we'll learn about the other number systems really soon. Okay, so you want to make sure you review this. I'll put up a worksheet and you can get that as well. And see if you can duplicate this on your own. Do you remember how the subgroups work? Let's go over some questions now. In example 1, we're just going to go over how we can use the real number line and if we can identify points on the line. Now you can use your calculator to do this. So where would you graph the numbers 3 2/10, square root 3, and negative 3 1/2 on the number line below? So here you see the number line. Now what you want to do whenever you do this is to put the numbers into decimal form. So that's why you want to use your calculator. 3 2/10 is already in decimal form, so let's just indicate where that would be. Think of it as money if you ever get stuck. $3.20 is a little bit more than $3. Less than 3 1/2, so it would be close to 3, but not quite halfway. Square root 3, well, you need to change that into a decimal number. So use your calculator, put into your calculator. If your calculator does not give you back the decimal form, let's say just you hit equals and it just puts again square root 3, then put square root 3 and then a decimal point and then hit equals, and now you should get your approximated answer. There's other ways you can do it using your mode setting, but that's the fastest way to do it if you're having any troubles. So square root 3 is approximately 1.73, and those digits go on forever. So what you want to do here is to round that number to 1.7-ish, and then you can decide where to put the number. 1.7 is in between 1 and 2. It's more than halfway, so you want it a little bit close to the number 2. And you rewrite the number in its original form, so square root 3. And then the last number, negative 3/2, should be a bit easier. Most can identify 3/2. If not, utilize your calculator. And so negative 3/2 using your calculator is negative 1.5. You can also change it to a mixed number that can help you as well. So negative 1.5 is in the negative round. That means it's on the other side of the 0. It's lower. Think of it as in money that you owe someone $1.50. Okay, so negative 1.5 then would be less than negative 1, so further left, but greater than negative 2, so somewhere right smack in the middle. And there you have it. Those are how you can put any type of number on the number line. Simply change them into decimal form. Let's say you get a question that asks you about pi. Well, if you remember it to be approximately 3.14, then you can just utilize your previous knowledge. All right, so example 2, what we want to do here is order the real numbers. That means put them in numerical order from least to greatest. And so we can use the number line to help us with these 3 numbers that are here. So we have our number line, and notice the first number is already in decimal form. Negative 3 technically is in its form that we need, is in integer form. And then the last number is a fraction, improper fraction, that needs to be rewritten into decimal form. And because it's a fraction with integers, we know that it's a rational number. So that will terminate. All right, so let's just change 12. Well, let's simply put negative 3 in there first. That's pretty obvious because we already have it on the number line. Let's do 12 and over 5, right? 12 divided by 5. If you put that in your calculator, remember the fraction bar means to divide, and the top number goes first. So 12 divided by 5 gives you 2 4/10. And then 4.5, well, that's halfway in between 4 and 5. 4 5/10 is about there. And right there, you can see the numbers in order from least to greatest. And so you can use the number line to assist you. And many students use that. I used to use it often when I was first studying. If I couldn't remember exactly where a number was, I'll draw a quick number line. It doesn't always have to go by ones. You can go by tens and hundreds and fifties just to get an idea where a number is located. All right, the last question that we're going to do here as an example are dealing with elevations. And so this question says a surveyor measured the heights of different elevations to be negative 112 feet, negative 216 feet, negative 97 feet, and negative 196 feet. Now, what that is referencing is something that may help us out using a graphic, is what we call sea level. So when you see negative something feet in terms of the elevation of a city or town, it's actually referring to where it's located in terms of sea level. Now, at sea level is 0. It's our origin. Above sea level could be like a mountain. Mount Everest is almost 30,000 feet above sea level. And then you have things like trenches. They could be thousands of feet below sea level. But sometimes on land, especially the further inland you go, in between mountains you get valleys. And valleys can drop down below the sea level mark. And so when you see something like negative 112 feet, well, that means it's actually lower than if we were closer to the sea. So now what we see is with this diagram, above sea level, you see the green units. Below sea level, you see the red units. And at sea level, you see the guys swimming there. Well, the scuba diver is in between 0 and negative 1 units. So we can use this visual graphic to help us with this question. Remember, to put numbers in numerical order means to start at the smallest number. So which one of these numbers is the smallest? Well, remember, the further down you go or the further left you go on the number line, it means you're going smaller. So although the digits are visually larger, you have to be careful. The negative sign lets you know that the larger digits actually mean smaller values. It may help if I change our digits here on the number line to hundreds. And what you'll see is that negative 100 is greater than negative 400. And negative 300 is smaller than negative 200. So go ahead and use that to assist you and see if you could get these numbers in order correctly before I go over them. You can always pause the video and push play once you're ready. All right, so that means our smallest value here would be negative 216 feet, and our largest value, negative 97 feet. And once we do that, we can put the numbers in order from least to greatest in numerical order, and there we have it.